Dear student, this is my lecture number 4 on 12 physics, unit number 1. In the previous unit, I have shown you the concept of electric field, what we understand from the electric field, and what is the physical significance. In this video lecture, I am going to discuss about the electric field lines. So, whenever I say electric field lines or anyone says that, then what to understand from that from the physics point of view. Okay, so first of all, electric field lines, okay, electric field lines, it gives you the information about the direction. Okay, this is the direction and the strength. So direction and the strength means it is a vector quantity. Now means it is going to represent a vector quantity. Okay, it is going to represent a vector quantity, because in the vector quantity you have a direction and the strength. It means that electric field is a vector quantity in fact. Okay, now if you have a q charge here, so if you place a q charge here, then what will be the what will be the influence or nature of the influence of this positive charge in this surrounding? To understand that thing, we need to understand the concept of electric field lines. That's why we use the concept of electric field line. Now you may have a question, sir, how to decide whenever I say that direction and the strength, then how to decide a direction? So our convention is that the direction of the electric field is always directed. Try to understand, in the direction that a positive test charge would be pushed or pulled if placed in the space surrounding a source charge. Okay, this point let me explain. Now first of all, try to understand the source charge. Okay, now the source charge can be positive also, and the source charge can be negative also. Now if I take the source charge as a positive, okay, and if I take a unit positive charge here, this is my test charge. Okay, this is my test charge and this is my source charge. Now whenever you try to bring this positive test charge in closer to each other, okay, then what is going to happen? These are the same charges, so they will repel each other. There is a repulsion. So the direction of the electric field lines for a positive source charge is your going out from the charge, or flowing out from the direction of in the outward direction from the position of your source charge. Now if your source charge is negative in nature, and if you bring a positive test charge, okay, this is your again test charge, let me write down, this is your test charge, and if you try to bring this test charge closer to each other, then there will be a force of attraction. Okay, so for a negative source charge, the direction of the electric field lines is inward. Okay, and for this one it is your outward. So this is the explanation of this paragraph. Now it is a useful means to visually represent the vector nature of the electric field. Okay, so to understand the thing that what is the strength of electric field at very particular point. Okay, this thing I'll discuss just now in few moments, and it is represented by a vector arrow. Now the pattern, okay, a pattern, several lines that extend between infinity and the source charge. Infinity, so now here is your infinity, and the pattern of the lines. Now see here the patterns of the lines here. For the negative source charge, the pattern of the line is inward, and okay, and for the positive, it is your pattern of the line is outward. The direction of the lines are away for the positive source charge, and it is directed towards for the negative source charge. Now here the another important points of the discussion here. Now as I in the starting of the lecture, the first point was that direction and the strength. So direction, now you have got the point, how to understand a direction. Now how to judge, okay, or how to estimate, or how to understand the strength of the electric field from the electric field lines. Now in this diagram you can see the three charges are there, A, B, C. Now in case of A, the number of lines are least. B has a higher number of lines as compared to B, and C has the highest number of electric field lines than C. So number of field lines is going to decide the strength of the electric field, or directly you can say the quantity of the charge. For example, if you have Q1, if you have Q2, if you have Q3, Okay, for example, Q1 is present at A, Q2 is present at B, and Q3 is present at C. Now as you can see here, Q1, Q2 and Q3. In case of A, number of field lines is the least, B has a higher, and at C is the C has the highest. It means that you can say that Q1 is the least, Q2 is greater, and the Q3 is the highest magnitude of the charge is present at the point number C. Okay, so in this way you can judge or you can estimate the quantity of the charge, or you can say the number of charges present here. Okay, may be possible that here you have only one positive charge, here you have two positive charge. I'm just taking an example. Here you can have three positive charge, means a system of three positive charge you can have. It actually represents. Okay, so now try to understand from the points. The common convention is to surround a more charged object by more lines. As I told you that now if Q3 is the highest, then the number of lines will be the highest. The density of the lines surrounding by any given object reveal the information about the quantity of the charge. So more charges, more number of lines will be there. Now the density of the lines at a specific location reveals the information about the strength of the field. Now you can, to understand this thing, I'll take the example of this diagram. Now you I think you might be able to observe the three circles has been drawn here. One circle is here and one circle is here. Okay, now if you see, so in this case the lines are more densely located in this region. Okay, so the closer to the charge, the line density is the highest. Okay, and as you move far from there, so the density of the line, try to understand the word. I am not telling the number of lines, I am telling about the density of the lines. So density of the lines decreases as you move away from the charge. So obviously it means that near the charge the electric field will have the highest magnitude, and as you move farther from the charge, the strength of the electric field decreases. Okay, now the line density, as I told you, that is in an electric field, line pattern reveals the information about the strength, see here, and the magnitude of the electric field. So this thing you can understand from this diagram also. Now important properties, that field lines start from positive charge as we have seen in the first slide, and end at the negative charge, and if there is single charge, then they may start or end at infinity. So we can take one point at infinity, one at the reference source charge. Two field lines can never cross each other, and if they cross each other, then it indicates that two different direction of the electric field, that is not possible. Okay, so that will be absurd. So two field lines can never cross each other. And the last one is that they do not form a closed loop. This about the closed loop we will study in the next chapter also. So this was a brief lecture about the electric field lines, and whatever the electric field you have understand it, if you understand that thing, then it will be easier for you to understand the electric field line. So thank you so much for watching this video, and take care of yourself.